affiliation. My name is Hamza, and along with my group members Noshad, Imtiaz, and Hamdard, we are here to present our final year project naming IPIA, Intelligent Pipe Inspection Report for Industrial Applications. Objective of project: to design and build a robot which should be capable of inspecting the industrial pipes where human access is not possible. The two basic questions that rise in everyone's mind are: what kind of industrial pipes should it work in? Does it work for pipes of different materials? And the answer is yes, it can work for all kinds of pipes for where it is made or for specific material of pipe. Important features: the unique design of robot allows to work for 8 to 12 inches pipe. Like we have made a robot that can vary from 8 to 12 inches. Vertical pipe climbing, it can also climb vertically or at any degree. Video feedback, it gives the video feedback, live video, real-time video. Detect temperature variations, detect any obstacle in the pipe, and the communication is done through hyperterminal. We have divided our project into some phases so that we can make the project according to our due dates. Theoretical design, mechanical assembly, driving circuitry and wireless communication, sensors and hyperterminal interface. Issues involved: limited budget, unavailability of ICs we required in Pakistan, mechanical part issues, and unavailability of required pipe. It was very tough to find a pipe of our own requirement. No one was there to make a pipe what we actually want. Here is the block diagram of internal circuitry. CPU we have used as a microcontroller 89C52. It is acting as a main hub. Two sensors are being used: temperature sensor and obstacle sensor. The analog input is sent to ADC0809 that is being sent to the 89C52. A power supply is used. Total we have used 4 relays: 2 for the direction of the motor control, 1 for the camera, and other for the bed for opening the obstacle. We have two options: we can either connect through wireless or through serial communication. For serial communication, we have used MES232 and then DB9 connector. And if we want to do wireless communication, Bluetooth transceiver is used and it is sent to the control panel using hyperterminal. Driving circuitry and communication. Sections controlled by driving circuitry. Forward and backward motion of robot. We can move our robot according to our desired need, either forward or backward. Sensing and transmission of data via wireless communication. All of the controls are done through wireless communication. Data reception and serial communication with PC. Wireless communication systems, pair of transmitter and receiver are placed at both ends. System is operating on Bluetooth frequency of 2.3 GHz. To simplify our project, we have used this Bluetooth device that connects the PC and our robot. Power supply. Robot contains different circuits that operates at different voltages. Like motor is being operated at 24 volts and the other circuit is being operated at 5 volts. So we have to maintain the voltage. Total 3 batteries of each 9 volts are used. For TTL circuit, it operates at 5 volts. We have used a voltage regulator so that it can maintain the voltage at 5 volts. Block diagram of circuit controlling the motion of robot. Receiver circuit is operating at 9 volts while motor requires 24 volts. Relays used for switching purposes. We have used total 4 relays. This is a block diagram. Output is coming from 89C52. It goes to transistor, which acts as an amplifier, then it goes to relay, and finally the motor. Block diagram of serial communication. Microcontroller, MES232 and DB9 connector. MES232 converts the TTL logic to logic 232 and sends to DB9 connector. Block diagram of sensing circuitry. Data from more than one sensor is being transmitted to the controller and then to the transmitter. We have used 2 sensors. It sends analog data to the ADC converter. It converts. The name of ADC converter is 0809. sends digital data to microcontroller and then to transmitter, Bluetooth transmitter. Now we'll call Noshad Imtiaz for further.
My name is Noshad Liaqat and I am here to explain about the mechanical part of our project. That was the proposed design that we had shown in the last presentation, and that is the final model that we have designed. Overview of the design. There are some springs which are used for suspension system. When the robot move inside the pipe, it will suspend itself according to the diameter of the pipe. Here is the motor used for rotating the head of the robot. And here we place a universal joints which are used for maximum rotation of the robot. Here we place circuitry and the battery as well of our electronic circuitry and the battery we place here. Now I will tell you about how the robot will move inside the pipe. Here is the motor used, which is used for driving the head of robot. When the motor move in clockwise direction, it will move in forward direction, and when motor move in anti-clockwise direction, the robot will move in backward direction in the pipe. Now I will tell you what we have achieved. In the last presentation, we have provided you the following specification of our project. Let us see what we have achieved and what we cannot achieve. Our robot is cheap, can climb up a pipe, sufficient for the circuitry, flexible in shape. Changes can easily be made in future, lightweight and simple design. The one thing we cannot achieve is our robot cannot climb up a pipe, because the reasons why our robot cannot climb up a pipe are due to the limitation of due to battery issue. We have not the powerful batteries. The powerful batteries are required to operate the 24-volt DC gear motor. And expenditure problem, non-availability of mechanical needs, the precise machining cost a lot, which come out to be unaffordable. Unavailability of specified pipe. This is the internal view of robot, and internal view of pipe and robot. The robot is moving inside the pipe. The special feature of this robot is the motor used here is, if we use a laser diode with this motor, this will act as this will use for welding, and if we use a buffer bit, if we use a buffer bit in front of this motor, it will use as a cleaning of pipe, and if we use a drilling bit here, we can drill certain holes inside the pipe according to our requirement. The advantages of this robot is this is used for opening the blockage and the obstacle sense, and this is also used for cleaning the pipe, and also we can see video inside in the totally video streaming of internal pipe. Now I will call my next companion, Mr. Hasdeep, and come about the sensing part of our project.
My name is Hamza Liaqat, and I am going to present the sensing part of our project. We have measured two parameters in our project. One is the temperature sensing parameter and other is the obstacle sensing parameter. For
नहीं ला के दिया
temperature
यार।
measurement, we have used temperature sensor IC, which is basically thermistor and transducer, which converts the temperature into volt. Transfer function is for 40 millivolt per degree centigrade. It means that when 40 millivolt is increased in its voltage, then 1 degree centigrade is increased in its temperature. Similarly, when 40 millivolt is decreased in the its own voltage, then 1 degree centigrade is decreased in its temperature. Okay. Temperature sensor. When temperature sensor sense the temperature, it will transmit to the PC. We have used AC converter, which converts the analog signal to digital converter, and this PC will show us a temperature principle. Sensor when sensor gives us some output, it will go to the transfer function. Transfer function will calculate the measuring parameter and it will show on us on a PC. Obstacle sensing. LDR is used for obstacle sensing, changes its resistance and tells when lights fall on it. LDR basically, when light falls on an obstacle, it will reflect back, and LDR can sense obstacle. Platform for other sensors. As I have described in the last slide, when sensor output gives some output, it will transfer function will calculate a measuring parameter. And according to the above principle, we have achieved creating a platform for many other sensors to measure other parameters. For example, cracks detection, hurdle detection, pressure detection, etc. Crack detection. For crack detection, a Hall effect sensor can be used. Hurdle detection. For hurdle detection, ultrasonic sensor can be used. Visual feedback. For visual feedback, we have used a wireless camera, operates on 2.4 GHz, and its range of camera is 200 meters. Now, by integrating different types of sensors, we can scan for leakages in pipes, can sense nuclear contaminations, detect pressure and temperature variations, scan pipe walls for small and large defects and cracks. Future advancements for welding. If we connect a laser diode along with this battery, we can use this for welding. For cleaning, we can use a buffer bridge. For sewing, we can use a diver.